Hello and welcome to another episode of the SBOM Academy. This time we're gonna go deep dive into vulnerability handling. I'm Ole Johansson and with me I have
Anthony Harrison.
live from Manchester, UK, and I'm in Stockholm, Sweden. Today is May 21. Why do we need vulnerability handling and why should we be interested at all? Well, there are regulations coming in Europe and in other places of the world that wants manufacturers to improve cyber resilience in products and services. But we also have the problem that was we saw with Log4j a few years ago, that as a manager of IT systems within an organization, we want to know if there are any new vulnerabilities coming up that needs our attention, needs our mitigation, and really fast action. And this is why we work with SBOMs and we check vulnerabilities and we start the mitigation process. So we need this to keep our system secure, our platform secure, our internal services secure. Well,
I think
when we,
I,
yes,
I was going to say I think this is sort of we see increasing numbers of vulnerabilities being reported, and I think every organisation wants to know. First question is, are they affected? Do they need to be worried? And if they are affected, then what's the impact? And then thirdly, how quickly can we fix it so our customers are then protected? And I think those three questions have always been there, but the time period now is getting ever shorter because once the vulnerability is out there, the bad guys are starting to make hay by exploiting these vulnerabilities. So it's a bit of a game to try and
oh,
keep ahead of the bad guys.
and the game keeps going on. We're seeing really bad incidents. I heard that over in the UK you had an incident with Marks and Spencer, and over here in Sweden we had grocery chains. We had all kinds of incidents in various databases for sports organizations and others, and this costs society a lot. And we need to start acting in a preventive way. So, in short, customers need to know the status of vulnerabilities in their software. Manufacturers need to make sure that their software is not endangering the users, and they need to be more transparent about the problems in the software and the mitigations needed. For the European Union, there will be a new CE marking, the CE mark that we know from a lot of hardware equipment we buy, will now also include software and include requirements on cybersecurity. And this whole new world is changing the industry. So the industry is really working hard now because when you build software today, you build like a Lego. You have components you take from various sources, you add a thin layer of business logic on top. And in many cases, you haven't got that full control over all the components you use. Maybe the commercial ones that you acquire from other companies, but the open source components, you got them for free. It's easy to integrate. It was a developer decision to be able to deliver this functionality needed faster and in a better way. So now we need to map all these Lego puzzle pieces called dependencies into a software bill of materials, a list of all the dependencies and how they interact with each other. We need to take that list and map with vulnerability databases to get a list of issues we need to take a look at. Now, when processing that list, most of the issues that we get won't affect the usage of our products, won't affect our customers, because there could be problems in parts of the code we don't execute in our product. So we need to figure out which of these ones that really should be a priority to fix. Which of these one can really put our customers in danger? And we need to start working on those. And when Log4j happened, the whole industry was coming to a standstill because everyone was asking everyone else, do you have Log4j? Do we have a problem? And it took so much time just to answer that question. And we need to automate the whole system so we don't get that pressure again. This information should be available for everyone and should be produced automatically.
Uh,
But yes.
I was going to say, I think Log4j demonstrated two very important things. One, people did not have that level of information to be able to quickly assess whether they were involved or not. And a lot of the ones that thought they were affected were just looking whether their development activity explicitly used the Log4j, and they didn't realise that they were implicitly using Log4j because of a component they acquired from another supplier. So I think it's important to say that vulnerabilities apply across the whole of the product, not just what you're developing or acquiring.
No.
And I think it's because all these components that you have in your SBOM contribute to your attack surface. And you have to understand that you're trying to, any weakness in that attack surface is going to be exploited or could be exploited. And I think what you also think, and you're rightly saying about we need to focus on a lot of the vulnerabilities are not exploited because there are going to be countermeasures. You may have built some countermeasures, or the vulnerability scope is not applicable. Maybe the vulnerability only applies in a particular hardware platform and you're using a different hardware platform. So I think it's quite important to say the vulnerability information is quite vague initially, and you have to sort of then dig a little bit deeper to try and exactly find the ones that affect you, rather than just doing something a very broad brush. It's the database says I'm affected, so therefore go off and do it. Yeah, that's just not feasible or tenable or cost efficient for your resources.
No. So trying to locate those that are feasible, those that are important to fix, will take some time, and we're coming back to that. But we need automation to be able to focus our time and our energy and our knowledge on the things that can really endanger our internal systems or our customer systems. So when writing source code, you end up with vulnerabilities in many different parts. And as we try to explain, that when you build with Lego blocks, one Lego block that you attach to your own code will bring in others. We call them dependencies, and there are many levels. It's like a family tree, with grandpa and all his kids and their kids. It keeps growing. So when you look at vulnerabilities in your product, you can use systems to find vulnerabilities in third-party code that you bring in, but you need expertise to look at your own code, and you need to listen to people who report issues in your own code, security researchers, customers, others. So you have your own code, and you have all the vulnerabilities that you get from a list running the SBOM towards a vulnerability database. Some of these vulnerabilities will actually be in your code path. They will be executed when operating your product. Some of these are marked in databases as already exploited. Hackers have used them. That means that the secret is out, that there are code pieces floating around on the internet that can be used towards your systems or your customer systems. So we need to triage and look at these different levels when we're working with our priorities. And when doing this, but if we really want automation and not guesswork, we need to have secure and reliable identifiers on all the components we're using, the whole family tree. And we use those identifiers, the names of the components and the vendor names, to look up in databases to find the problems. And from that operation, we'll get an overview of all the known issues in your software system. But this relies on the identifiers. We need strong names, and we need to be able to understand how we find the names that are used in the vulnerability databases. And vulnerabilities, as I said, this is something traded on the net. When someone finds a vulnerability that can be exploited easily, you will see thousands of attacks. And more complicated ones have a higher value but can still be traded. So you have attackers and you have defenders, and we as defenders needs to share this information, what we see. And there are many sources that cooperate here: cloud services, firewall systems, other things, to give us a better view on what's going on and what's been attacked. But you have to act quickly. This is not taking months and months. The attacks start very quickly because the information is a valuable asset for these people. But that doesn't mean that the attacks stop after a short while. We still see attacks on Log4j, and Log4j has been around for a long time. And this is because there's profit in it. People haven't upgraded the systems. They haven't found that they have Log4j exposed to the internet in a vulnerable system. So
I
there's a
think
long tail.
yeah, I think it's also that, if you're using a component that is widely used, let's say a browser, for example, then the attackers are going for the large, a bigger slice of the pie. So if you're using common components, then these are the ones that are more likely to get targeted than something that is less common. It's not saying you ignore them, but there are a list of 150 products, about 150 products, which are what we'll call critical, and they are probably underpinning most of our software products these days, whether they're operating system or language ecosystems or libraries. And these are the ones that as soon as the vulnerability is in a browser, then off they go. How can we use that?
Yep, yep, of course. I mean, cost per CPU resource, cost per minute is really important for the hackers as well. Unless they really do targeted operations, they're out for after something else than your little device. And this is why we keep stressing the fact that even small devices that aren't that important in your IT infrastructure can be critical, because they can be the way in. They break into that device and then they move horizontally to other systems. So the CRA really enforces that you have to take a risk-based cybersecurity approach for every product that's connected, indirectly or directly, to a network. So even if you're selling toys or gadgets for the home, you will have to understand and work with cybersecurity. You will have to look for vulnerabilities in your products. And there are things we see. There are public databases, but those are the reported vulnerabilities. Those are the public ones. There are lots of stuff beneath that. The not reported third-party vulnerabilities and issues in each and everyone's own code. We that work with a lot with open source, we get reviews. People look at our software, they tell us how to do better, they tell us when we have problems because the source is available and they're helping out. But for manufacturers, they need to employ people to do code reviews, to find the vulnerabilities in their own code. And I think that's a huge area that we haven't begun seeing yet. But the CRA and similar legislations are targeting this, making sure that if there are incidents, even in the manufacturer's own code, they have to be reported to the authorities.
I think the not reported third party vulnerabilities is quite interesting, and I think in some cases third parties will update their software because they find a vulnerability. It might not have been detected or reported by a researcher, but they find it and they upgrade the software. So this is why it's important to be monitoring the versions of the software, updates of software, maybe because they've found a defect. Might not have been a vulnerability, it's just a defect that could become a vulnerability. So it's just being aware that that's why when they're updating, adding new features, they may be also fixing defects at the same time. It might not be
Yep.
explicit, and that I think is it's difficult. It's it's often difficult to see because we hear people say, "Well, I'm only going to upgrade that component if they had a vulnerability reported." But okay, that's one good reason, but there may be other reasons why you should also be updating ahead of the game.
But I mean that's true, and we need to start working with this, and we need to put our minds into a new mindset where we work with vulnerability management. And this, if you don't do it right, will be a source of wasting a lot of hours, a lot of manpower and money on the wrong things. Uh, Many people talk about that as security theater. So we need to automate where we can, and where we can, that definition is changing with AI and other systems that will help us go through our code base and do things more cleverly. This is an ever evolving landscape, it keeps changing. But we do need to automate so we get information from our vendors, from the open source projects that we use in an automatic way and can manage our systems. But let's look at vulnerabilities, what it is. We mentioned that a couple of times, and there are, of course, many different definitions. We agree that it's a defect, it's a problem in the software that is of, in a way, usable by a hacker, an attacker, to come in and do bad things, unexpected things in your system. Get privileges, reach data, reach other systems in a really bad way. So we have attackers that exploits a defect in our system. When we look at the Cyber Resilience Act, there's a definition, and it's very similar in the NIS2 regulation as well. They categorize vulnerabilities in 3 different classes. One is there's a vulnerability, there's a problem in the software, we think it has to be fixed. Then we have something where we actually understand already that it can be exploited by a hacker. This can put our customers in danger, right? Their systems or information or ourselves. The third level is exploited vulnerability, where there's proof that hackers are using this vulnerability already, either by itself or in combination with other vulnerabilities, but there is proof around. And in the case of the Cyber Resilience Act, when you have proof of exploits in your products, you have to report it within 24 hours to the authorities. So when you look at vulnerabilities, you get that list from running your SBOM every night, and you see the systems. You need to figure out whether this code that has a problem is used in your product. Is it essential, or can you disable it? And can it be disabled by configuration? That means our customers can actually protect themselves without updating, and you get more time to update and fix the software. So managing and assessing vulnerabilities, placing them in these categories, and working with mitigations and priorities for mitigation. Is this something I need to do ASAP, or can I fix this in my regular update that's scheduled once a quarter? That's something we need to really work on in the organization. So let's look at a possible workflow for automation. The goal, the overall goal is to keep our users secure, whether they're customers or internal within our organization. We should lower the risks of using the software, whether the software is standalone or mobile app or embedded in a system, or even a truck or a robot or a machine, a drone. We should automate as much as possible, and we should move forward with automation as new automation becomes available, so we can focus the manpower on the important issues. If we look at such a process, we have a database in the middle here, the blue ring, that is the SBOM database, where we have all the SBOMs for all our systems. We automatically get inputs from upstream vendors and open source projects. And in that information flow, we can get information about possible vulnerabilities as well. We operate this database, the SBOM database. We compare it with the CV data. So we get a list of current non-fixed vulnerabilities. And we move into the yellow area, and this is where we need people. We need to run an assessment process, and we need to be able to focus on the important issues. And this is where we need a lot of help, a lot of automation, and systems that can assist us in this. When we find a problem that needs mitigation, that affects our customers, well, we can do one of many different things, but we need to mitigate. Can be that we inform our users that we found a problem. This is what you need to do to protect yourself. We will soon come with an update. You can update. If that's easy, you do that directly in step one. Otherwise, you do that in one of the following steps. And make sure the users know that there is an update. They are expected to update, otherwise they're at risk. Or you could say that, well, this is not critical, it's not even in code path, but I want to get rid of this anyway if we change our code in the future. So you need to update, but you can do that in a planned way somewhere in the future. Now,
I was just saying before you move on, just go back one slide. I think one of the other things is when you scan your SBOM, you're going to get a list of vulnerabilities for all your components, whether these components are directly used by your software or indirectly transitive within your software. And when you are looking to the mitigation, if the mitigation involves a third party to be responsible for doing that update, then you, in the COA case, you have to probably work with that upstream developer team to try and get that update available as quickly as possible. Yep. So you're not completely in control of everything, but you are responsible for managing that process. And and there is always the danger that you find there's a vulnerability in a piece of software, and that developer is no longer maintaining that piece of software. So that is another part of it. We talked about SBOMs in another session, where you have to be almost proactively monitoring the component health. Is it being maintained? And if it's not being maintained, then maybe you should be looking at updating your components before they become exploited, because there's a high likelihood if they're exploited, they're not going to get fixed. So there's a lot behind that very relatively simple diagram.
Yep. Absolutely. But one of the core pieces is the ability to actually match the component names and versions and vendor names we have in our SBOM with information in the vulnerability databases. And this is an area that Anthony and I have spent a lot of time on, because currently the way the system has been working, a third party have registered the company name as well as the component name. And they haven't done so in a very strict way. So many companies have many variants of product names and company names. So there's a lot of guesswork needed today, and we need to fix that in the systems. And organizations like OWASP, OpenSSF, and the CV program is working hard to find a solution to this problem. But from the IT systems overview, for the internal IT systems, you typically have an asset inventory system where you have an ID on your asset, because you want to know when you get vulnerabilities from the SBOMs, which equipment, which software, where is the software installed in our network, in order to make priorities. If a software that has a vulnerability is facing the internet in a customer support system, that is critical. But if it's only used internally in a system that's only turned on once a month for doing a special routine, that's not high priority. We can keep that turned off while we fix the internet facing things. So being able to link from assets to SBOM is also critical. And that's something that's typically overlooked in many systems today. And we need to find standards here. We need to find solutions to make this very efficient and automatic. So to summarize, this was a quick introduction to vulnerability management. Of course, we have longer introductions that we can run in trainings in your company. But SBOMs is the heart of the vulnerability management process. And the component name in the SBOM is critical in order to be able to operate SBOMs and find vulnerabilities in the database. The detection here is an automatic process that should be running at least once a week, if not every night, in your systems. But the assessment of the list that you get out of that operation, that's mostly today a manual process that requires knowledge about the components, knowledge about how you use them, and how they are depending upon each other. And with that, I think we're done. Do you have anything to add, Anthony?
No, I think one of the things is that if you don't do it, then you'll eventually get caught out. Potentially, the vulnerabilities could then become an issue. There are also, certain vulnerabilities are going to lead to certain more extreme impact on your organization. Particularly if it's on a critical asset. So understanding the criticality of your assets within your business is key. If you are protecting, say, customer data or personal data, then that system is probably of a higher priority than one that's just, I don't know, doing a printing system. There's probably, you can probably do without it for a day. So understand the criticality of your assets, I think, is very important to support your vulnerability management. So you're right, SBOMs are part of it, but it's also part of the business context as well, needs to be seen. And the more frequently you do it, the quicker you can reduce your exposure. So yes, I've heard monthly, I've heard weekly, I've heard daily. Vulnerabilities are being updated hourly. So obviously choose what's appropriate based on your risk appetite.
Yep. And it's all about the risk appetite. And the risk appetite for manufacturers have been extremely high. And now legislations are forcing them to lower that and be more proactive and think more about the customer security in addition to their internal security for their production systems. So with that, we say thank you for this time. Follow us on YouTube, LinkedIn, Blue Sky, or other channels. And we look forward to seeing you soon in SBOM Europe. Thank you and goodbye for now.
Bye.